Stephanie, who actually worked a lot with Lewis on this project and helped quite a bit. So our next volunteer, we get no one. Here, okay, take it away.
Hey everyone, I'm Eric. I go to Trinity School. And for my starter project, I built the Minty Boost. It uses a repurposed Altoids tin and AA batteries to charge your phone. So here I have a phone cable, a USB charger cable. It plugs into this female port and goes the other end into your phone. Then it starts charging. My phone is off. Okay. It's shutting down, please. Okay. It runs on AA batteries, and it's really good for emergencies. It's not supposed to run that well with iPhones, which is great because I lost my iPhone a few months ago. I have to use this one now. And so for my main project, I built this personal power plant. It uses solar and kinetic energy to charge it. So here's a solar panel. I tested it in bright sun. It gives you a lot of voltage, around 5 volts. And here is a air system, which if you use a little handle, I'm using a chopstick for a handle, it turns the stepper motor shaft, and that in turn goes through these two rectifiers made of rings of diodes. And that converts the alternating current from the stepper motor into a direct current, which is really good for charging batteries, since an alternating current will make the battery charge and discharge. So I'm gonna, if you keep turning this, it's gonna eventually charge the battery up to its full capacity. I'm using an IMH battery. It's 7.2 volts. And for a handle, I'm just using a chopstick. I went out during break and stole like 10 of these from a restaurant.
We don't condone stealing at BlueStamp either, just so you
It was free. So one of the cooler parts of my project is the visual multimeter that I added. So here, I don't know if you can see it, but on the prototyping board, I have 3 Zener diodes, and Zener diodes are special compared to regular diodes because regular diodes just prevent a current from flowing in a certain direction, but for a Zener diode, if a voltage is high enough, it can safely allow the current to flow in the opposite direction. So I purposely put these 3 Zener diodes, each of a different voltage, one higher than the next, than the one before it, in a parallel circuit, because parallel circuits have the same voltage at every point, but a different current. And I do put them against the current, or backwards, sort of, on purpose, so that if the current was high enough, then it would flow past the diode. If it wasn't high enough, it'd stop there. It'd go through a series of resistors, and then I'll go to an LED. So the lowest one is green, the yellow one is the next one up, and the red one is the highest. And then here it flows into a battery. So when I'm not touching anything, there's no sunlight in here, and these lights aren't bright enough to use the solar panel on. And I'm not going to turn the wheel. If I push the button, oh, wait. If I turn this and I push the button while I'm doing it, the LEDs will light up, and so that's telling me how much energy, how much voltage is going into the battery. The reason I believe why it's not working right now with the, oh, it is working. My battery going in is because I left it plugged in for a week by accident, and that causes the battery to discharge back into the circuit, which was a big problem for me at first because I would charge the battery for like half an hour the day before. I'd leave it plugged in overnight, and then when I came back, it was dead, and I thought it wasn't working, so I had to recharge it to see if it would work. And then I figured out I should discharge, unplug the battery. Now I know that. And here is an output terminal. I've learned through research that a terminal is a really elegant joint that doesn't necessarily use solder. So here, this output terminal gathers everything I have coming from the solar panel and the stepper motor and with the gears. into here so I can plug in or use wire jumpers to plug in different electronics to this, and it will come from the 7.2 volt battery and charge whatever I want. Questions? Yeah.
How do you make the case?
What?
How do you make the case?
Oh, the case. Right. So they call it for an acrylic box. I realized I could have used not cardboard, but something like wood, perhaps, because the case I actually I think we found it on Amazon. It's like but it's supposed to be a football case for footballs. That's why it's so big, which I didn't really need. It's made of acrylic, and this is one of the tougher parts of my project. It's the reason why I now hate acrylic. Acrylic is really hard to drill. It melts at a really low temperature, so that drilling was mostly okay. There were times because the box is really awkwardly shaped, I couldn't clamp it down properly, which could have been a bit dangerous, but I managed to clamp it down properly. The worst part, the worst part about using acrylic was making holes like this, because the drill bit wasn't big enough to drill a hole this big. So I have to make a smaller hole and use a Dremel to sort of shave away the sides. And because acrylic melts at such a low temperature, it would sort of make this paste and melt the acrylic, and it started plugging up the hole I just drilled into. So I'd have to like find a solution for that by drilling a hole underneath the surface in the wood underneath, and the melted acrylic would go there instead of plugging up the hole. And eventually made all these holes, which is good. Yeah, Ben?
How did you get the gear to turn so smoothly and power the crank?
Well, at first I just used a plain hole, and I just for this axle I just used a binding post, which was really bad because I had to space it out with a ton of washers, and then after I turned it for a while, it just snapped and like exploded washers everywhere. So instead, someone suggested to me, Ben suggested to me that I use a ball bearing, because ball bearings are really good for turning something inside without affecting anything else. So I epoxied the ball bearing to the gear, and then I epoxied the inside of the ball bearing to this really long screw. I used washers and a nut to hold it in place. And as I said, I'm using a chopstick for the handle. And now it turns pretty smoothly. Sometimes, because this isn't too stiff, it'll wobble a little and slip. But I can fix that by tightening the bolts inside and maybe epoxying it so that it won't wiggle anymore. But that's how it works.